Okay, hello everyone again. This is the third time I'm trying to record this. Today I just wanted to run down the architecture again and to just, I don't know, say things out loud. Maybe it will help me work on things. I'm feeling a bit stuck and I thought that maybe reviewing everything that I've done up to this point will help me work on the project. So right now, if we just run the program, we see the chessboard in front of us, and I can make a move. For example, I can move the knight from b1 to c3. This is just some debug information. These are the bit boards corresponding to the pawns, to the white pawns, to the white rooks, to the white knights. We can see that we moved the white knight, so it's different. Okay, it's different. Nobody cares. Okay, and if I make a move, or like if I pick up a piece, it will print out the legal, not very legal, but the legal move it could have done. So for example, I picked up the knight from b1, it figured out that I picked up the knight from b1, and it prints out the legal moves it could have made. Okay, let's see. I think there's a bug here. If I move from a2 to a3, for some reason it doesn't print out the white pawn move, but I already fixed it. So I think something bad is going on. Maybe if I try to rebuild it, e2, e4. Now it works, but I don't. Maybe I didn't save it for some reason. Okay, nobody cares. Okay, so if I pick up a pawn from the second rank, it says that I could have moved one piece up or two, but if I pick up the same pawn from, if I wanna go from e4 to e5, now it realizes that I'm not in the very first pawn rank, so I couldn't have made that jump, so I couldn't move two tiles up. I can move from e5 to e6, and I could try to move from e6 to e7, but what are these? Yeah, I did make that move. Okay, I could make that move, but it's not actually black pawn. Pick that. Wait. Okay, so e6 to e7. e7 to a8. Okay, didn't prune the legality tree there. Okay, so basically what I'm trying to say is that there are some pieces, like for example the queen. Let's just move it to a3. It says that I could have moved it along this diagonal, but it doesn't actually check right now in the logic that that move is actually legal. Now it prints out the legal moves that it could have made, but there is no logic inside the main loop right now to actually check based on this mask. So yeah, the next step would be to actually make good movement rules, and then after that check the tile that I want to move with this legality mask, or I don't know how you would say it. And if it returns the move back, then it means that we wanted to step onto onto a tile that wasn't illegal, and then we actually make the move. But right now I could move from I don't know, from a3 to h4, which is not actually a legal move because this bitmap doesn't actually not correspond to, but doesn't. Yeah, okay, that's an illegal move. The queen can move like that, but yeah, I still print out the legal move. I don't know, map. Yeah, okay, yeah, that's basically the biggest thing that I did. I think that I didn't upload yet. That if you pick up a piece, it will print out the legal bitmap. I don't know, the legal bitmap. If we move from, I don't know, if we move this bishop to, let's say, it's a bit hard to line this up to like a f4. The bishop's moves are okay. f4 to e5. you can see that the bishop's moves create a diagonal, and inside the generating move function I actually prune the legal move bitmap with the occupied pieces. And this is a bit wrong because because I shouldn't prune it with every kind of piece. I should only prune it with the white pieces. So okay, for example, if I pick up the white bishop from e5 and move it to, I don't know, f6, this is a legal move, you can see that now it says that I shouldn't be able to, for example, move this bishop to like g7, so to f6, g7. It says that it shouldn't be a legal move, but in real chess you can take an enemy piece. So we need to keep in mind that I should be able to pick up a piece, but I can't make it so that I will be able to, I don't know, for example, let's just move the f1, nobody cares, f1 to a5, and I shouldn't be able to pick up here d8 because there was a pawn blocking it. So if I am generating a move, I should first check if it's if I'm moving in a line. I should first check what I am jumping into, and if I'm jumping into an enemy, I should still add that to the bitmap, but I should stop the stepping in the function. Yeah, that's basically it. I can also move the king. Okay, I can move everything, but there is also a bitmap for the king. e2, e3, yes, e3, e4. Castling and legality checks for king are like checking is still not made yet. I can move the g3, yeah. I also did it for the rook, so I can move it to e1. Yeah, it also prints out the, yeah. And basically the queen is just combining the rook's movement and the bishop's movement. Okay, so yeah, basically this is what I've did. This is what I updated it with. And yeah, for now I'm going to just run through the whole program, which is, I think, more than 1,000 lines. Jesus. Now it's 1,300 lines roughly, and it's going to not double, but I think I need to add a plus 500 because I am dealing with the black and white pieces differently. So I have a function here called generate the black king's move. Oh no, I already did the black moves. Okay, so then I didn't do the black queen. I am dealing with the black and white pieces differently, so there's a distinct function for generating a move for a black piece and the white piece. Okay, this is it basically. Let's just move to the beginning. Okay, and for the remainder of the video I'm just going to go line by line, try to explain everything that's written there, and maybe that will help me structure my thoughts better. Okay. We have includes, nobody cares, okay. I have type definitions. Whenever I'm writing, for example, I want a new bitboard for, I don't know, something for like the empty pieces, so empty pieces equals something like 0. I should write like this, so it should be an unsigned integer, an unsigned 64-bit integer, and I don't know what the theme is, but I saw in one YouTube video where some guy wrote it using a type def, so he just writes U64, and I like that convention, so I copied it. So whenever I wanna get a new 64-bit number, I basically just write U64 lol equals 0. I don't know. Yeah, so that's basically it. Okay, I have a few definitions. These are used for when I am checking things in a for loop. So I have the PC's bitmaps in oh, I didn't change this. So for example, the white pawns bitboard is initialized here. This is the basic starting position for every piece. And for example, I can okay, when I was first writing the program, I needed to remember that okay, the fifth or the sixth, I don't know, the sixth bitmap is for the white kings or king. You know, let's just keep it logical. We won't have more kings, hopefully. Okay. I needed to remember that okay, the very first bitmap was the white pawns. After that came the white rooks, but it's a quite an easy thing to just define white pawn as like the 0th, as 0, white king as 5. So basically, if I wanna look at the piece, the bitmap for the white kings, I can just write pieces white king, and then it would give me back the 6th bit board, or like, yeah, the 6th one, I don't know, you go from 0, but yeah, the 6th bit board. Okay, so that's why we do some definitions. Okay. I defined some other numbers as well. These are basically just the ranks and files in a chessboard. These are used for masking purposes. So for example, the topmost rank, if we, I don't know, print it down as a 64-bit number, would look something like this. So this is the first rank, no, this is the 8th rank, for example. So I won't explain how bitmaps work, but basically the very first line is are ones, the rest are zeros, and this is how all of the ranks and files are, I don't know, defined. These masks are really useful when I am doing these are very useful when I'm trying to generate moves, or like generate move bitboards. For example, yeah, let's just check the white rooks. The thing I'm basically doing when I'm generating a white rook bitboard is I am moving up, I'm stopping if I encounter a piece, then I am moving left, I stop when I encounter a piece, or hit the side of the map. So here, for example, should I explain everything? I don't know. Basically, if I wanna do a logical operation where I checking if we move off the board, so if I am at the very, yeah, if I'm at the very top of the board, I shouldn't calculate any more steps upwards. So okay, so I wanna stop the movement, and I can do that by just checking if I'm at the very top rank, if I'm at rank 8, and I can do that with a logical AND operation. If the start and the rank 8, the starting position is a place where I'm standing. If the starting position and the rank gives back the starting position, then we stop the movement. And I basically do this for every direction. It's more important when we are going left and right with the rook. So for example, because I am generating current. Yeah, so I am generating, or no, I am changing the bit boards using left and right shifts. So basically here current is just the starting position, and I shift it to the left by 1. And if we didn't move off of the board, then basically the current position, or like the cross position is cross or current. It's really hard to explain everything without like a drawing, but nobody cares. This is my motto, nobody cares. Yeah, okay, so yeah, the files and the ranks help us with logical checks. If I wanna move off from the board, or if I'm at the very edge or something, it helps with masks. Okay, nobody cares. The car move 4. This is basically the character that we input whenever we what do I wanna do? Yeah, okay, unused parameters. So basically when it asks us to enter a move, we basically input 4 bytes here. This is why we need to say that the move car is 4 bytes. Nobody cares, everybody gets it, okay. Yeah. So yeah, we need 4 bytes because we input one rank, one file, one rank, one file. So E2, E4, these are 4 bytes. Okay. In there, okay. These are some integers. This is from tile to tile, from index to index. I am storing the tile for several functions, and I am storing the index for several functions. So these are the indexes of the pieces. Okay. I don't know if I even need this, but this is just okay. This is basically int x equals 1, I think. So this is basically what I did, but for a 64-bit integer. I don't even remember why I needed this. I have no idea. So this is basically just 1. ULL means this is an unsigned long number. So whenever I'm stating a 64-bit number as a variable, I write ULL at the end. Okay. Legality flags and legality mask is not yet implemented, but the main idea is that I would have an 8-bit number like that, and I have an 8-bit mask, and 1 bit would correspond to for maybe this bit would correspond to, I don't know, is the, I don't know, the place occupied where we wanna go. Maybe this bit would correspond to I don't know, was the king in check and something. So basically we do 4 checks after I make a move, for example E2, E4, I do 4 checks, for example. Maybe we need more, I don't know. And if all of these return 1, then we would compare it to the legality mask, and if we get back the legality mask, then with like a logical AND operation, then I can say that okay, the move was legal, you can make the move. But for example, we fail one of the checks here, and we don't get back the legality mask here. 1, 2, 4, 8, yeah, so this is, yeah, if you don't basically get back 15, then, oops, something went wrong with the move, so that's not a legal move. Okay. Bool debug is basically just, if I write this to true, then after I run the program, I will get some debug information. I don't know. I can see the bitmap here, and I don't know if this is a good naming convention, but for me this one line is a bit board, this one 64-bit number, and the whole map, or like the whole memory segment that I don't know, holds all the positions, I call these a bitmap. So the whole bitmap consists of all of the pieces, the empty tiles. I think I even store the move. So this is the move from, and this is the move to. So for example, A2, E3. A2 would be the move from bitboard, and the A3 would be the move to bitboard. Okay, nobody cares. 40. I don't know. Yeah, and if I bring this to false, then it won't print the bitmap. Okay, I have a few printing functions. These are not really interesting. I have a void print board. I have a void print board debug. The print board is basically what prints the board in the terminal. Yeah, here. I also have a print board debug, which I think is bugged. Print board debug. Yeah, which I had to debug. Okay. Board display. Okay, these are the arguments it needs. So if I just make it, it's a bit buggy now. Okay, this is the debug view. I don't know why. I think this is a bit better looking board, but I don't know. I am experimenting with how the program should look. And yeah, basically, I think it should work. Yeah, 5, G1, 3. Yeah, basically it's just another type of display. I'm still experimenting with how I want it to look. Okay, we have yeah, perfect. Print indices. This holy shit, this there's just something in the TV. Print indices basically just, I can show it, I guess. It basically just prints indices. This basically just does this. So this was helpful for me in the beginning, so I know that this tile on the H1, this is the very first tile. This just counts up from 1 to 64. Nothing interesting, okay. Okay, print indices, print values. Print values. I think print values is what prints out the bitmap. Yeah, I think, yeah. Binary printer is basically what prints out the binary value of a 64-bit number. This is why I have a 64 prefix here. This basically just I think from left to right or from right to left, it just moves through the bits. I don't know where I have it defined or initialized, I don't know how to say it. Yeah, we have a, I think this is where I needed the 164. Yeah, it basically just moves from the, I think this is in the very first, it moves from the leftmost bit and it just moves the index to the correct position. It does an AND operation, and if it returns 1, then we put a character 1 here, and else it will put a 0 here, and after every 8th bit it puts like a space there. So yeah, nothing fancy. The binary printer square basically just does the same thing, but after every 8th place it doesn't print a space, it prints a new line character, so it actually shows as a, I don't know, as a visible bitboard, I don't know. And update board just basically updates the board after every move. I think this is a very ugly looking function if I remember correctly. Void update board, where is it? Move bitboard. Binary printer square. Where is it? Move tile bitboard, yeah. Print board debug, yeah, it's very ugly. Update board. What did I do here? Yeah, it basically loops through the whole bitmap and changes the board display. It changes the board display like string, I can say maybe. It's the board display character string, or I don't know how you say it. It's just a list of 64 characters, and I think the very first one is the A8 piece, and the very rightmost one is the H1 piece, and basically just updates the board display like character, and then yeah, the board display is then used as the, oh no, it was other way around, and the board display is then used in the printing functions. So yeah, so I won't go through that, it's not interesting. Okay, we have the door. Okay, I think this is the most I don't know, headache inducing part in this program, for me at least. We are basically trying to convert a move into a tile and then a tile into a bitboard. Okay, when I'm explaining it, it's not that difficult, but basically we take the character move here and we wanna figure out which tile we are sitting in. I'm just gonna go here and then explain it. Whenever I'm inputting a move, I'm inputting characters, so like char. Those have actual values based on the ASCII table. I don't know what's the correct name for it, but there's an ASCII table that you can search up online. So for example, I think A is how do you say it? So basically if you print out, let's say like, I don't know, character equals A. and you want to print out the character using something like this, so character, this will print out A. Okay, but if you do this in the printing function, this won't print out A, it will print out an actual number, because every character is saved internally as an actual byte. And I think, if I remember correctly, 96 or 95 is correspondent to A or something like that. You can look up the ASCII table, nobody cares, let's just write 96. So basically, using this, I can figure out which tile I am picking up. So if I say E4, then this would be the move 0. So the E component is move 0 or something like that. And I don't know which value is E from the top of my head, but let's say it's like, I don't know, 99, I don't know, would be as like a 8-bit number. And if we, no, it wouldn't be a 99, I think it would be like something like, let's cheat a bit, I think 101 or something like that. So if we subtract 96 from it, we will get back, I think, A, B, C, D, E. We would need to get back 5. And basically, we just calculated that the E character is the 5th column. The same goes to the rows. So basically, if I don't know, if we input the move as E4, let's just write it down here, E4. So then move, E4 would be the first character in move. So we would have some kind of number, I don't know, 52, I think. So we need to calculate 52 minus 48, and I think we will get back 4. Yeah, okay. So basically we just calculated from a character, from the character 4, a symbol, from the symbol 4, that it's actually the 4th row. And now we can get back tile if we just, this is some kind of mathematics, so basically just, okay, you basically have now the column and the row, and you need to get back an index, or you need to get back a tile if you go from H1 to A8, and this is how you do it. So basically this function converts E2 to the correct tile. Okay, move to tile does the same thing. Okay, nobody cares. Okay, move tile bitboard basically requires, from the tile it generates the bitboard, which we will need when we wanna do logical operations and masking. Yeah, okay, this is where I need the 164. Okay, we basically take the 64-bit number 1 and we need to shift it to the left by how many? We need to shift it to the left depending on the tile that we just calculated. So if we need the 5th tile, then we need to move 1, not 5 times to the left, but only 4 times, because then we will get back the 5th tile, and nobody cares. And so we need to subtract 1. So we basically just have 1 and left shift it as many times as we need. Okay, nobody cares. Okay. So now we have a 64-bit number, which is a bitboard now, which we will need to use during logical operations. So, okay, so basically we decoded E2 into the correct bitboard. That's basically what we did. Okay, and now move bitboard index gives us back the specific index used in pieces. So let's say that we have the move again E2. It will generate a tile based out of that. After that, it will generate a bitboard here, and now we need to get the bitboard of the move that we did, and how do you say it, and do checks on it. So basically we need to check if the move that we did, we got the beatboard of it, if you, what's the word for it? Összehasonlítani in English, fazd meg. You need to compare it to every bitboard in the bitmap. So first we compare it to the white pieces bitboard. If we get back the starting bitboard back, then we know that we have picked up the white pawns, and we do that with every bitboard. And this function has to stop at one point, because if we put every bitboard on top of each other, we would get back a 64-bit number with all ones. So this has to stop at one point. So basically, using these functions, you can input a move. So let's say E2, and then you can. What the fuck is going on the TV? Oh, yeah, it's Brickleberry. Okay, cool. Can I kill yourself? Okay, so basically you get E2, for example, and the computer can decipher, oh, you picked up the white pawns. So these functions basically do this. Cool. Nobody cares. Okay, let's move back to here. Yeah. And now we get to the interesting part, which I did this weekend. How does this work? Basically, these are the functions which generate these legality bitboards, I think. I don't know how you say it. Okay, now I know what it does, but I don't know how to like explain it. So when I run the program and write E2, E4, these are the functions that generate these bitboards. And I won't really go in depth because I already talked about them a bit when I looked at the rook. But basically, we need to figure out where a piece can move. So, for example, if we go down here to just the white pieces move legality checking functions, the white pawn is pretty easy. We have a starting number, the white pawn move. This is just I think this is from going to the right. This is 00008 times and then 1. I think that's the number, and we basically just shift it around. So for example, if I'm sending an E2, I have a bitboard for it, then its move bitboard should be just the same bitboard shifted to the left 8 times. And I just do a quick check here. If the start if the starting position lies on the second rank, this is basically what it does, then we can also add another move to it, shifted to the left 8 times. Then that would mean that we can jump up 2 times. Okay, this is basically the white pawn move. The white pawn attack is not yet done, but this would be basically just moving, I don't know how you say it. So this would be current shifted to the, I don't know, left attack, anyádba. Left attack should be just, so you have a pawn, you can attack to the left, and then you can attack to the right. So this would be shifting 9 times, and then right attack should be shifted to the left 7 times. We could have something like attack equals left attack or right attack and return attack or something like that. This is basically what we'll need to do, but not like that. Okay, nobody cares. Okay. The generate white knight move function just returns. Oh, I didn't talk about it, but we can talk about it now. the way I did the... Oh, no, I think I recorded this. We calculated all of the ways the white knight can move, and we saved it in this, I don't know, party memory, block of memory, I don't know how you say it. Basically, we just save 64, 65, okay. We save 64 types of numbers here, and all of them correspond to a bit board matching a knight attack pattern. And basically that function just returns the correct bit board based on the tile we are sitting at. So we have the, I don't know, this library of like knight moves, and I've saved them in a way that if we are sitting in the eighth tile, then the 8th entry in that library, I don't know, is the correct one, and we just return that. Okay. The generate a white rook move is pretty straightforward. We first move up. If we can move up anymore, then we stop. If we then move down. Yeah, we stop when we can't anymore. And basically when we're stepping, and we could step 1, then we basically add that step to the bitmap, to the bit board with an OR operation, or with OR logical function. Then we move left, then we move right, and then we return the cross that we have generated. The white bishop move is basically the same thing, but we need to do more checks because I don't think we need to do more checks. What did I do here? Yeah, for example, if I move to the right with the rook, I check if the move... Oh, I didn't write these. I don't care, okay. I didn't change these, okay. Basically, we just check if we move of the board, checking if tile wraps around the board. Isn't this the same thing? Checking if we would move off the board, then we stop. Checking if the tile... Oh no, because no, start represents where we're sitting right now. If we're sitting on the H file, no, if we're sitting on the H file, then we stop the moving rest of it. Okay. If the current corresponds to the where the start, and we want to check the next step, this is what I call current. If the next step is on one of the side files, no, okay. If the next step would wrap around to the A file, then we break again. Yeah, okay, that's what I did. Nobody cares, okay. Yeah, basically we did the same thing. These are just different directions, I think. Right up, yeah, okay. Yeah. Why did I name this left up and right up? Why didn't I name it like north, south? Nobody cares, okay. So basically we just move north, west, southwest, I don't care. Yeah, we generate these bitmaps the same way, and yeah, generating the white queen's moves is basically just generating a white rook move, a white bishop move, and then ORing them together, and that would combine these bitmaps. Okay. Yeah, the white king move is the lamest one. We basically just check to the north, check to the south, check to the east, check to the west, check to the northeast, northwest, southwest, southeast, and this is an ugly function, but I don't know how I could write it better, because this checks everything, but this kind of feels like the infamous how to check if a number is odd or even. So like, I don't know if you guys know it, but there was the Yandere simulator game, and Yandere Dev, the creator of the game, I think this is how it went. He made a legendary function that will check if a number is even or not, and it would basically consist of, so if number equals 0, then even. If the number equals 1, then it's odd. And he will do this for like hundreds of numbers. It was insanely funny. And I have the feeling that I'm basically doing the same thing, because I'm just only checking one tile ahead in every direction, and I feel like there has to be a better way to do this, but I just can't figure it out. So here it is. We are doing bitwise operations and just few checks. This shouldn't take up lots of like CPU power. I don't know. Yeah, I think I just copy pasted the black moves. Okay, this is quite boring. Okay, what else do we have? We have the generating bitboards related. Okay, here's the int main. We are basically setting up the board. So just quite bored. I'm bored. We basically set up the pieces, the white pawns, the white rooks. And here is something that I should change, I think. I've set empty tiles as this number. This is correct. This corresponds to the actual empty tiles in the chessboard when you start the game, but this is a bit of a wrong approach. This can be easily be calculated, and I think I've tried to do something like that, but it messed up my very primitive move making thing. This whole thing is going to get obliterated. This is bad. You shouldn't write something like this, because I don't know. This is doing very... This is basically just picking up a piece, putting it down, swapping the pieces in your hand, and then putting down the piece that you picked up later. So basically you're just swapping pieces, but this shouldn't be done because there is a bug right now in the project. So basically if I write A2, A4, A2, I don't know, B3, A2, B3, it will hallucinate a white pawn there. And I think this works for everything. So B2, B3, B2, B3, no, B3, C3, B3, C3. Right now it's hallucinating a white pawn, and I don't really understand why, but nobody cares. So yeah, this is a quite a faulty logic here. This will get changed, but this will be, I think, a bit more. It will have a bit more clarity when I'm actually updating the empty tiles after every movement or something like that. So first I should have every white piece. I have it here, but I don't really do anything with it. I need to have every black piece. I can get every white piece if I OR all of these together. I can have every black piece if I OR all of these together. And then I can calculate the empty tiles by ORing together all of the pieces that's down there, and knotting them. Logical NOT do a logical NOT operation on it, and and then we will get every empty tile. I should do that, and I think I will next time, but okay. I also saved the move from and move to bitboards here, which I don't think is a good idea, but I don't know, nobody cares. Yeah, I have some move and bitboards here. Yeah, this is where the knight moves reside. Yeah, basically this is the number I was talking about. The white pawn move is basically just this. So if you're sitting at h1, this is the pawn move that you could do. So when we generate a white pawn move, we just shift this number to the left as many times as we need, depending on which tile we're sitting at. So that's quite easy. And the knight move is, yeah, I already talked about it. This is just a whole map of all the knight moves that we can do. Yeah, setting up the characters for the board. This is just for visual stuff. So if let's say I change this to like, I don't know, Q, and then we make the program. Now empty tiles are the character Q, which is not interesting at all. Let's just change it back to the dot. Or, I don't know. Yeah, let's leave as a dot, okay. That's okay. Storing the position for graphical purposes. Oh yeah, when we have the bitboard, we calculate every tile's actual, like, this is just graphic stuff, I don't care. We have a masterful game loop, while game loop is true, then we do this, yeah. Okay, now, this is the whole game loop, this is where everything happens that we see when we run the program. We basically reset the move character array, or I don't know, the from tile, the to tile, the from index to index, and the bitmap of the from and the to moves. We reset everything. I think I wrote down memory safety measure. I don't want garbage code or like garbage data here. These are important whenever I'm doing the moves. Or which I don't know if I should do this, because before anything happens, I am asking the person to enter a move, and then this will always be overridden. But oh no, maybe this is a good idea because this is a loop, so we would, yeah, okay, yeah, resetting this is a good idea, because after we made a move, we did everything here, then we move back, we need to make another move, but this should be reset so that nothing bad happens. I don't know. Yeah, we ask a move, scan F, we need a space here for, I don't know, I don't remember. Yeah, exit the program if move 0 is Q, so basically if I just write a Q, then the whole while loop is broken, and then the program stops. Yeah, closing program, goodbye. And this is, I think, how I could have more, I don't know, comments here. So that's, oh yeah, let's just try it. So maybe if I have move 0 as H, then let's say print F. This is the help command. What will happen if I do this? I think something will break because we didn't actually input a move, but now we're going to calculate everything as if the move I've written down was 0, 0, 0, 0. You know what, let's just check it. Just check what happens. This is the help command, yes. And now it thinks that I picked up the black rook. Okay. Yeah, so basically now the while loop is still faulty because yeah, I should do things a bit differently. Yeah, so this is a bit wrong. This only works if move 0 is Q, because it kills the whole while loop and the program stops. So yeah, I don't know how to say this, but this is, I think, like this is the player input logic. Yeah, this is the player input logic that we should look at later. Okay. Okay. And now we do all of the calculations and conversions. So basically from the move, we can calculate the from tile, we can calculate the to tile, we can calculate the bit boards from these with these functions. We can calculate the from index and the to index using these functions. And here I have a variable called current move. And yeah, this is what I think I did yesterday or the day before. We have a huge switch statement. Check if a move is legal or not. Basically right now I'm just checking which piece I have picked up. If this case is a white pawn, yeah, if the from index is a white pawn, then we say that the white pawn is picked up. Or if it's a white rook, then we say a white rook is picked up. And I just print out the current move, which is just the generated legality bitmap checking stuff. This whole thing is under construction. I need to write several more functions where I check if a move is legal or not, and then if a move is legal or not, then I actually do the move. And this whole thing, this should be replaced with a function something like make move. something like this with some kind of variables. So yeah, this whole thing, this whole block should be one single function, and it should be inside here based on checks if a move is legal or not. Okay. Making the move. Yeah, we print some debug information if debug is false or if debug is true, and yeah, printf closing program goodbye, return exit success, which basically is zero, but it looks cool. Okay. Yeah, I think I moved through all of these functions. Yeah, okay, I think this is the end of the main file. This is all I have written over a course of, I think, over a year, and I think for like 6 months, I only had maybe this function where I had the board display pre-programmed with several characters and then just print it. I didn't even have the update board function. I didn't know how to update the display using the bitboards, and this is a very ugly approach, I think, but it works. I don't know, I'm working in C, it's quite fast. It works. Okay, this is the whole main.c. I hope I didn't break anything. A4, A5, yeah, A2, A3, A3, A4, I don't know, A1, A3, A3, H3, okay. Those work. Okay, I can exit the program. Okay, everything basically works right now. I also have a readme here. Very, I don't know. Can be played in the terminal, I think that's better. What's next? Okay. I went through all of the things that I've written right now so that I can gain clarity on what I should do next. Okay. Implement the movement rules correctly for every piece. This also means that I should implement the right attacks, ampersand checks somehow, and castling steps, I think. Yeah. Oh, and I should have some way of how do I input left or right castles in? Okay, casting is going to be a bit of a problem because right now I am inputting, if I want to move from example A1 to D1 as with like a rook. But oh no. Yeah, because the king can only move one tile regularly. So if I just, for the king A, B, C, D, E, if I input E1 to G1, I think you wouldn't be able to do that regularly with the king. You can only do that if the rook is in the right position, so that anytime you input E1 to G1, then it should make the castling, if castling is still legal or is allowed. Okay, think about castling move input. Okay, I think we did that, but yeah. Okay, make move function. I need to replace movement here. Do the legality masking stuff, okay. Inside the switch statement. Okay. You can exit the program by inputting Q as move. Okay. Yeah, implement the movement rules. Yeah, okay, basically that's it. So, okay. My next step then should be to actually make these functions perfect. I think I did lots of good things by considering when to give the extra type for the pawn. I can mirror it to do that for the black pawn as well. I need to do the pawn attacks, and I think I need use 64 generate white pawn and passant, something like that. I should have something like this, and oh yeah, and if I'm picking up a white pawn, I think I should either or all of these together when I'm checking movement, or I should have other functions as well to check. Yeah, okay, I still need to think about it. Okay. The pawn is the trickiest because I can only do en passant when I'm at the correct file, or like, I don't know, and in the correct row, and only when a certain enemy pawn movement has been made. So I think I should do these case by case. Okay, nobody cares. Okay, I can think about that later. Okay, so just make all of these generate pawn moves correct, and maybe I should make a generate white king, queen castle and king castle bitmap as well, which we would only show inside the switch statement when a certain criteria is met. So for example, nothing is blocking the king on the back rank. Okay, so this is what we need to think about. And then also how to implement the actual rules. So for example, a very naive approach would be, let's say I move with the white knight. Okay, the white knight is it's printed that the white knight picked up. The current move is generate white knight move, white knight, yeah, and print it. Okay, now I should have something like if the current move and if the current move and which one is the from the bitmap? Which one is it? How did I name it? Move from, yeah. So if current move and pieces move 2 equals pieces move 2, then we should have a function make move something, yeah. So yeah, if this happens, so that our move is actually legal, so that the current move bitmap and so we have the circle or something of the knight move. So if that and the move 2, that specific tile in the bitmap, if we end it together, we get back the move 2, so that it's a legal move. We actually make the move, so we would do this. But if that's not the case, so we need an else statement. I don't know, printf incorrect move, and then we will need to loop back to this while loop. So this is what I'm saying, that this while loop is not actually good. Oh yeah, and maybe I should have another different function here, so something like move reset. Yeah, so I could put these things inside move reset, because I have update board, yeah, move reset, update board, ask for a move. I could maybe put these inside another, no I couldn't because a function can only, it doesn't need to return anything, it can just update stuff. Yeah, maybe I could have a function called calculate move. So this would basically generate tiles, indexes, and bitmaps and indices. Yeah. So now here we could do. Maybe this could be like another function, like check if move is legal. I don't know if check if move is legal is true, then make move or something like that. Okay. So maybe a good idea would be to I should just create them like that. Okay. Make move. Okay. Make more abstractions. So we need to abstract these. I need to abstract my main function down into specific functions, because this thing that I'm doing right here, for example, that I've already said that I'm doing, this naive move making is very bad. Yeah, okay. So next time I will focus on abstracting these functions, abstracting the whole main.c, the whole main function. Okay, abstracting the main function. I forgot the other thing. Abstracting the main function. I'm so tired. What's the time? Oh damn. Yeah, abstracting the main function. And yeah, changing the game loop. Yeah, this will require lots of pen and paper, because I would need to do like a whole flowchart, because we need to start the program and then we need to make a loop where if the move is incorrect, then we need to move to the start of the loop. Okay, and if I write that, I will still need to worry about then if I made the move, then it should be black's turn, and I need to think about how to do that. Maybe I could have like a while loop. Okay, the first while loop is the white's turn. This is one loop. After that we enter a black's turn, so this is black's turn, and if we exit that, we do some calculations or like print in the board and stuff, and then we move back to the beginning of the first while loop, and then we enter like a smaller while loop for white again for black. Okay, before I forget, one big loop, two smaller loops, white's move, black's move. Okay, I think that's good. Okay, abstracting the functions and fixing the whole. Okay, making legal move generation functions. No, finishing the legal move generating functions. Finish the legal move generating function. Correct the while loop, one big while loop, two smaller ones inside, white move, black move, beginning, okay, beginning, abstract, more, several more functions. Okay. Igen, yes, papa. Okay. Do these. Okay. I can save them. What am I doing? Okay, I can do this. I can git add main. I can git add readme. I can push everything to the graveyard known as GitHub. Updated readme. Yeah, updated readme. Let's just have git push origin main. Okay, I think this video is also a success because first, nobody's going to watch it. Second, I could talk to myself for an hour. I think it was actually a whole hour that I was talking to myself. And the lighting is awful. Oh my god. Okay, so I talked to myself. Very good. I think I have a bit more clarity on what I should do. And yeah, if someone actually sat through all of these, I am so sorry. This is a piece of unwatchable content. But just as a, I don't know, mi a tanulság angolul? Yeah. One thing that you can take away, I think, is that I think you should read everything that you have written, try to figure out why you did them and how you can fix things that you don't like. I think for me it was important here to notice the bottlenecks, the alleyways that I drove myself into. There are lots of things I did wrong, but I also remember why I did them, and I know that the things that I wrote are just temporary. For example, the pawn movement function. I think I know what I need to fix, and I will fix it. I just need to have something that I can work with. And I think it would be, just as a closing thought, I think I should make a video where I just talk about why I'm doing this project, like an actual scripted video, because for me it was really helpful to just pick a project like this chess program and just doing it. The only I don't know, tutorial I was watching was I think the Sebastian League's videos for like inspiration. It was really cool. I watched another video, I hope I won't forget to link it, who was talking about his experience with writing a chess engine, but he was talking more about the engine part, not the program, not the game part that I am currently working on. I watched those and I've skimmed over the chess wiki, and the whole idea, or like the whole inspiration, was that you can use bitboards, you can use whole 64-bit numbers to save everything. You are literally manipulating the zeros and ones inside the program, which I find really cool. This is like for me this is programming, like manipulating the zeros and ones deliberately and doing these logical operations on them. I know that modern programming isn't like this, not even mentioning the AI stuff, but nowadays if you're working like in like Python and stuff for like even beginner projects, you don't work with like 16-bit numbers, 32-bit numbers. You work with strings, with like just ints and floats, which are doing basically the same thing. Like an int is like 4 bytes or something, like 2 if you're, I don't know. But I think this project really scratches that itch where I just wanna look inside the program and just manipulate everything, which I think is really cool. Yeah, I think I will make a video about just this whole thing of like, don't look at too many tutorials, just start writing stuff. Even if you can only just print out a chessboard with like pre-programmed stuff, it looks cool, it gives you the inspiration to work. Yeah, okay, I won't talk anymore. I need to go to sleep. It's 2 a.m. Thank you for not watching, because nobody's watching this. It's so cool. Thank you for, I don't know, thank you.